Hello everyone, my name is Supriya Bhosle, Assistant Professor, Computer Engineering Department from AISSMS Institute of Information Technology. Today we learn about the concept related to data structure and algorithm. Topic name is linked list. First we'll see about the introduction of linked list. So, in linked list is basically a very commonly used linear data structure which consists of group of node in a sequence. So here to store a similar data in a memory, we are using a linked list. So while the element of an array occupies a continuous memory location, those of linked list are not constrained to be stored in an adjacent location like array. So the individual elements are stored somewhere in a memory, but they are linked with each other so that it look like a sequential manner or linear type of data structure for the storage. The order of the element is maintained by explicit links between them. For instance, suppose we are considering the marks obtained by the different student can be stored in a linked list is just the example of linked list. So the linked list is basically the collection of node or the sequence of node. Node is created by using a two fields. The first one is a data field and the second one is an address field. So data field, in that we are actually stored the data inside the linked list. Like suppose you want to store the marks of student, so data is represented in an integer. Like suppose student is appearing for examination, he or she got 90 marks out of 100, so the 90 we can say as a data, and the address of the next node is nothing but the second field we are considering in a node structure, that is a address field. So address is nothing but we are linking the node with each other to create a chain like sequence. So address is always store the address of next node which you want to connect. Suppose you want to store the marks of 5 students. Okay, so the first node is attached with the second node is attached with third, likewise. So here linked list is used to create here the trees and graph. Suppose you are considering in this diagram there are the three nodes. There are the three nodes. The first node is this one. So we are going to use the concept of header here. Header is one type of pointer we are going to use. It stores the address. The pointer is actually used to store the address. So header is a type of pointer. It stores the address of first node. Suppose you are considering this is a node structure. Okay, so the first one is your data field and the second one is your address field. Header is always store the address of your first node. What is the address of first node? Suppose the 100 is the address of first node, that is stored in a header. After creation of your first node, it is linked with your second node. So in the first node address, we are storing the address of next node. What is the address of next node? The address of next node is 200. So 200 is stored in the address field of first node so that it is linked with the second node. Same for second node address field, it store the address of next node, that is nothing but the last node. Last node address is 300 and it is stored in this field of second node address field, so that the second node is connected with this third node. After that, this third node is a last node, so the address field of last node is always denoted with a null because it indicates that this is the end of your linked list, means this node is not further connected anywhere. So this will be considered as its end of node and address will be denoted with a null. Here in this example, it create a 4 node structure, 4 nodes in a sequential manner, and the node structure is having a two field, data and next. So data, it stores the characters H, E, A, and P, right? And this first node is connected with the second by using this address. So these are the all pointers so that they are connected in sequence. The last node address is going with a null that indicate that this is the end of linked list. So there are the total 4 nodes in a linked list, which is having the data, the type of character. So this is about the data organization or the data structure. Is actually classified into the two types. The first one is a linear data structure and non-linear data structure. Linear data structure is again classified into sequential organization and linked organization. Sequential organization, the example of it is an array. Array is actually used to store the similar kind of data item, but it requires continuous memory allocation for the storage. Linked list is again used to store the similar kind of data element, but it does not require any kind of continuous memory allocation. They are linked with each other by using a node structure. A non-linear data organization is classified into the two types, general graph and the tree. So this is about the example of linked list of an element in a figure. First figure, it shows the n number we can store by using a linked list, member 1, member 2, member 3 up to member n. And at the end, we are denoted the end of linked list with a null pointer. Same, a linked list, suppose you want to create a linked list of a weekdays. So each week is having a 7 days. So we are created a 7 nodes here: Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. Sunday is the last day, so it is not connected further anywhere. So it is denoted with a null. So this is a general concept to creation of linked list. So this is about the advantages of linked list and disadvantages of linked list. So the first advantage, they are dynamic in nature, which allocate the memory when it required. So it always use a dynamic memory allocation at a runtime. It create a memory space when you want to insert a new data in a linked list. Suppose you want to delete previously added data, so it just deallocate a memory at a runtime. The next advantage is insertion and deletion operation can be easily implemented. It does not require any kind of shift or the extra efforts. They are required such a kind of things in an array when we are doing a insertion and deletion. But in linked list, we can easily implement a insertion and deletion. The next advantage is stack and queue can be easily executed by using a linked list concept. The fourth advantage is linked list reduces the access time. There are some disadvantages of linked list, like the memory is vested as a pointer require extra memory for storage. Here in linked list we are created a node structure. Each node it uses the address, or the address is nothing but the one type of pointer which is connected to the next node in a linked list. So it obviously requires extra memory for the storage to connect between the nodes. The second disadvantage is no element can be accessed randomly because it has to access each node sequentially. So sequential access is allowed only in a linked list. No random access is allowed. The next disadvantage is reverse traversing is difficult in a linked list. Thank you.